And so what would you get if you did that?
So would that be just 4 times 1, add 1, so it'd be just 5?
Yeah. And then?
And then, I'm not sure what the 20 is.
So the idea is you do that 20 times, where it's like when you're doing this in GCSE, you would use N, and now it's R. So
Okay.
so first R is 1, then R is 2, then R is 3, up, and you stop at 20. So you do 20. Yeah.
So how would I write that out?
So the idea is, let's see. So for the first one, so 4 times 1 plus 1, 4 times 2 plus 1, 4 times 3 plus 1. So it would make a sequence, sorry, it would make a series. 5 plus 9 plus 13, all the way up.
Okay.
How would you add up a series of numbers?
Would you do it? Is it? I can't remember. Is it A?
So sum to n. Let's see. I believe it's n over 2, 2a plus n minus 1d.
So then for this, I would put 20 over 2.
Yeah.
Then 2 times 5.
Yeah.
And then that'd be 19.
Mm-hmm. I'll just put in as 20 minus 1 and let the calculator do the work.
Okay. And then D. Is that just 4?
Yep.
So it goes up in 4 times. So that's... I've got 860.
Sounds right. And you can also do these with the calculator. Now the very simplest questions you can do with the calculator. The rest of them you can't.
Okay.
I'll just make this a bit bigger so you can see it a bit easier. So make that bigger. Make that bigger. So it is menu 1. So just the run matrix. Just that normal one.
Yeah.
Let me see. I believe then it is option. F4 for calculate. F6 for write. And then F3 for sigma.
Oh, okay.
And so you can use any letter. I'll just use X because it's the easiest. You could use R if you wanted.
Okay.
So on the bottom is X equals 1. In the bracket is 4x plus 1. And then on the top is 20.
Okay.
And you get 860. So it looks good. And there we go. That's 860. Yes. So I feel like you could try using your calculator for one of these.
I'll try A. Yeah, I've got the same number as that.
Okay, and you could always just edit it to be 5 to get the second one. And we could just check our answers. And so the sum to 12 is that. And then this one down there. Let's just see how they did it. So they did it using the geometric series formula, a times r to the n minus 1 over r minus 1.
Okay.
Yeah, so this was, if we go back, so this is an arithmetic sequence with a common difference, and then this one is a geometric difference with a common ratio because it's to the power of, and so you would select based on that. This is a 3-mark question. I think you'd be fine with that. I would use the calculator. I think that's the right way to go about it. Same with that one. Yes, let's try this. That's a K on top. Try to note to myself.
So will we use the equation from before? Because we know what it equals to.
Yep.
The arithmetic one.
Yes, arithmetic.
Do we know what A is?
You could find A yourself.
Okay. Would A for this bit be just 3 times 1 and then adding 6?
Yep, 3 times 1 plus 6.
So that'd be 9.
Yep.
make it into a like a quadratic.
So that's what part A is for.
Yeah.
Tell me if you're stuck. Did you get 12 for D?
No.
What D did you get?
I got 3. But I don't know what I've done.
No. You're right. It's 3. Because second term is 12. 12 take away 9, 3. Sorry.
Okay. I'm not quite sure how they've got to them brackets.
So what did you get? Did you expand it out?
Yeah, I've expanded it like that.
So K over 2, 18 plus, was it 3K minus 3?
Yeah.
And so K over 2, let's say 3K plus 15?
Oh, I know what I've done. I didn't do the 15.
Oh, you didn't simplify it, was it?
Yeah.
Okay.
And then that's equal to 750.
Yes.
If we bring the 2 to the other side,
Mm-hmm.
and then we've got 1,500.
Mm-hmm.
We can expand the brackets. And to make it a quadratic, just bring the 1,500 over to the other side to minus in it.
Mm-hmm.
And then, yeah, I get them brackets, I think.
Okay, yeah. And so 3K squared plus 15K minus 1,500 equals 0. And I think at that stage, it's okay to just put it into the brackets.
Okay.
Part B.
So based from them brackets, we can figure out.
Mm-hmm.
So it's either k equals 20 or k equals 75 divided by 3.
What is that?
That's just 25.
Because you're doing a lot. What happens there?
Oh, it's minus.
Yeah, minus 25. How could you check your answers?
We could use that setting.
Yeah. So I'm gonna check. Option. Calculate sigma 3 I'll use x just 'cause that's quicker. Sorry, 3x plus 6. X equals 1. And then the top I'm going to put minus 25. What's this about?
Would it have to equal 20 because you can't have the sum of minus 25 items?
Correct. So we reject the negative one, and so k
Okay.
equals 20. K equal, reject negative, answer k equals 20. Yeah, because you can't have minus 25 numbers in a series. Yeah.
Yeah.
So just watch out for that. Any questions there?
No.
Okay. Yep. So just do the formula, sub it in. If they don't give you A, figure it out by subbing in the first term. If they don't give you D, figure that out by subbing in the second term and doing first term. Take away second term. Do you know how you'd find the common ratio if it was geometric?
I can't remember.
So common difference is term 2 take away term 1. Common ratio is term 2 divided by term 1.
Okay.
So very, very similar question. Try this one.
So will we be able to do the geometric sum equation
Mm-hmm.
and do
So sum to n is a to the power of, a times r to the n minus 1 over r minus 1.
So we know A would have to be 8.
Yep.
Would R have to be 2?
The common ratio, yep.
So by simplifying it, it just goes to 8 to the brackets 2m minus 1.
8 times 2n to the minus 1.
Yeah, because if R equals 2, the bottom would just equal to 1.
This is for the common ratio, is it?
Yeah.
So yeah. So common ratio. So on the top would be 4 times 2 squared, which is 16. On the bottom it is 8. 16 over 8 is 2. So A is 8. R is 2. And I suppose N is K.
Oh yeah.
Okay.
So if we expand that out, 16 to the power of n minus 8 equals 262,000.
Um,
Is it that?
So you subbed it in. So you've got 262,136. So that's equal to 8 times 2 to the power of k minus 1, is it?
Yeah.
And that's over... that's what you were saying, it's all over 1.
Yeah.
Okay. So 262,136. That is equal to 8 times 2 to the k. Because of BIDMAS, you have to do indices before multiplying, and because you don't know what the index is, the simplest form is just 8 times 2 to the k. You can't actually expand it.
Okay.
And that would be minus 8, yeah. Okay.
So we added the 8 over.
Mm-hmm.
Could we then divide by 8?
Yep. I'm going to do is as 136 plus 8 over 8.
Yeah.
And my guess is it's going to be 32768.
Yeah.
Okay.
So if we take natural logs,
Mm-hmm.
it'll then be that k equals...
Well, this is a show that, so let's actually just show it. So let's say ln
Okay.
2 to the k is equal to ln the other one.
Yeah, I've got that answer.
So
So you bring the k down.
I think that's the important bit, to show that you bring the k down, and then I think you've shown enough. So yeah, you have. It just for a show that question, you just want to make sure you actually kind of show that you've known the laws of logs.
Okay.
Okay, so k is this, and then b. How do we do b?
Could we use this on the calculator?
Yep. And so I put ln 32768 over ln 2 in, and it's exactly 15.
Okay. So then we could just make the bottom equal to 16.
Yeah. That's it.
I've got that to be 8126464.
4. And there we go. 8126464. Any questions about that?
No.
They just did it a slightly different way. Just want to see this one. So that's 16. So that will be 20 to 1 minus 15 to 1. Maybe, I think this is based on an old calculator method.
Okay.
Okay, so this one is similar to what we did before. Is this worth doing, or you think you'd be okay? You can try it if you want.
I think I might be okay with that one because that's
Yeah.
just using the arithmetic, isn't it?
Yeah, it's very similar. Okay. Any idea about this one? So this relies on kind of previous knowledge.
So if it's a sequence, that's geometric.
Mm-hmm.
Does that mean A R
The
to the power
important
of something?
the important bit is this convergent. Do you know what that's about?
Does it mean it's tending towards something?
Yes. So if it's an infinite sequence, so you probably remember the sum to infinity is equal to a over 1 minus r.
Oh yeah.
Do you know when a sequence will be convergent?
I only know when it's converging towards 0.
So usually, like if we'd gone with this previous sequence, let's say this one, if this tends towards infinity, basically you'll just get infinity. Like it's just going to keep getting bigger and bigger and bigger. And in fact, while you were doing it, I put it into my calculator in the table. I did the first 10, and you can see here how it's getting bigger. 10, 11, 12, 13, 14, and then 15 was the answer. But it's just going to keep getting bigger and bigger and bigger. So that's going to be what's called divergent. If it is convergent, that means it's getting closer to a number, and the common ratio tends towards 0. The common difference would tend towards 0. Something would tend towards 0. The difference each time. And basically, the common ratio has to be between 1 and minus 1. So it'll be a fraction, like a half or a quarter, 2/3, something like that.
Okay.
Minus, 3/4. So how could you use that? What is the common ratio?
Is it 4?
So common ratio term.
Oh, it's gotta be. Is it between what's making it go from 4x to 16x squared?
You tell me. What is 16x squared divided by 4x?
Is it not just 4x?
Yep. And that's because the first term was 1. So 1 times what gives you 4x? It's 4x. So common ratio is 4x. So they wanted a range of possible values of x. We have a range of possible values of 4x.
Oh, so we would have to make it between minus 1 over 4 and then 1 over 4.
Yes. And 1 over 4. And a different way of writing that is x is less than the magnitude of a quarter.
Okay.
Okay, part B.
Can we use that sum to infinity equation?
Yep.
So is A 1?
Yep.
And then is R minus a quarter or a quarter?
Common ratio, we said R was 4x.
So do we just input 4x there?
Yeah.
Okay. Does x equal 1 over 5?
Yep. X equals 1 over 5. And I just used the solver in the calculator. 1 over 1 minus 4, x equals 5. X must be 1 over 5. And there we go. Magnitude of x is less than a quarter, and b is a fifth. So same thing again. This time you're using the sum to infinity formula. For if it's convergent, you know, if it's an infinite geometric series and it's convergent, you're using sum to infinity, and r is between 1 and minus 1.
Okay.
This is very similar to what we did before. Is it worth doing?
No, I think it's okay because I think the only problem would be just inputting what k equals.
Where, into the bottom one or just in general?
No, into the bottom one. So we would just have to find out what them logs are. So
Come on, put it in.
so if it was okay. That just equals 9.
Yeah, and so what are you putting for this one then?
So for R, it would be 10.
Yeah, and I was just checking when you said it would be a problem. It didn't seem like much of a problem. I didn't think it would be. Let's see this one. Oh yes. Okay, let's try this one. How do we do this?
Do we have arithmetic and geometric?
Yep.
Or is it just?
Yep, we have both.
Okay. So would we have to figure out what it would be for the arithmetic one first?
Yep.
And then for the geometric?
Yeah.
So for the arithmetic part, I got 205.
Okay.
And then for that one, I got, for the geometric, I got 1,223.
Should be just 1,023.
Oh yeah, sorry, it is that.
Okay.
I misread it. And then that equals the answer.
Yep.
So then I just show them adding them together.
Yeah. So
Okay.
yeah, you basically just have to do them separately and then add them. Any questions there?
No.
Okay. And they showed it by actually doing the putting it, subbing it into the formula.
Okay.
Let's try part A for this one. Yeah.
So it would have been from -1 to R is bigger than it, and then to +1. Is it 3x?
Yep.
So then that would be meaning it's -1/3 between 1/3.
Mm-hmm. And would you know what?
So does that mean it 1/3 is bigger than x?
Yeah. Do you know how to write it in magnitude?
Oh, would it be in modulus brackets?
What would be?
So the lines outside of it.
So I'd write it as x is less than the magnitude of 1/3.
Yeah.
That's it. And how would you do B?
Would we use the geometric sum?
And do you remember what it is?
Is that a over 1 minus r?
Yeah. So go on, try that one.
So A for this one. Is it just 3x?
R is 3x.
Oh, A is just 1.
Mm-hmm.
And then R is the 3x.
Mm-hmm.
And then that equals to 2. Is x a sixth?
Yeah, that's it. 1/6. Great. Any questions there?
No.
Okay. X is a sixth. So sigma notation. How do you feel about that?
I think that's a bit better.
Okay. So the only thing after that is recurrence relations, which is this different notation for the same idea. But I think you got the main thing. So let's see. Excuse me. Sorry, go on.
Okay.
Let's see. So, sigma notation uses stuff like the formulae that come before it, arithmetic, geometric, and sum to infinity.
Okay.
So you just have to sub them in. So it's basically, you sub in. The long way is an equation that would create. Sorry, it's like a formula for creating a series of numbers. So 5 plus 9 plus 13. You can do it just by using the formula n/2, 2a plus n minus 1d if it's arithmetic, or you can just use your calculator. These were geometric. You can use a calculator, or if it's a kind of show that question, you have to use the geometric sum to n formula.
Okay.
So these were all very similar. So this was a show that, and you had to show it was a yes. How do you get A and D for these questions?
So for A, we would just input R equals 1.
Mm-hmm. And for D?
And then D would be inputting 2 for R and then take them away.
Yes. How would you find the common ratio if it was geometric?
Would we input the power to begin with 1, and then for the second one 2, and then divide them?
Yes. So this one you had to, and I'll just show all of the steps that you go through. Why did we only get k equals 20 for this one?
Because you can't have a negative.
Yes.
For sums.
Yes. Kind of negative number of terms. So this one you're okay. Show that one. Yeah, just do your ln. Just show all the steps. That one, just put it in the calculator to get what k is, and then sub it into that. Let's see. So this one, yeah, if it's an infinite series and it's convergent, yeah, if it's convergent, then it's an infinite series. And so R has to be between -1 and 1 to make it converge, like, because you're adding like a half plus a quarter plus an eighth plus a 16th, and you're adding very, very little extra every time to the point where you're just adding 0. And so it converges. In this case, it converges on 5.
Okay.
Find the value of x. Just sub, yeah, a, r, and x into the formula and solve it. Just like with the other ones, that's what you're doing basically. Yeah, same thing. A, r, and x, sub them in and solve it. Yeah, so that's sigma notation. How was that for you, Eva?
That was okay. Thank you.
So is there anything in particular you want to do for next time?
I think I might do some applied maths as I've got an exam next week for applied.
And what topic for applied?
It might be probably more do statistics. So I probably might do normal distribution.
Normal distribution. And have we done that before? Oh, do you know off the top of your head?
I don't know, but I think it might be more the hypotheses testing for.
Yeah, that's the year 2 stuff, I believe, is it?
Yeah.
Yeah. Okay. Yes. Any questions for me in general?
No.
All right. Well, well done, Eva. You did great. I look forward to chatting you again next week.
Thank you.
All right. Have a good week. Goodbye.
Bye.
Okay.